Hello everyone, this is Dharambi sir here. So today we are going to start chapter 10 of grade 11 maths, which is straight lines. And the topic of today's video is slope of a line. Okay, so let's start. Now first few important points to remember that we have already learned in grade 10th, that what is the coordinate of a point. So in the figure you can see that P is a point whose coordinates are x and y. Then the perpendicular distance of the point P from y-axis is called abscissa, and the perpendicular distance of the point P from the x-axis is called ordinate. Okay, and we have already learned that x and y-axis are called axis, coordinate axis, and the equation of the axis is if x-axis then y is equal to 0, and if y-axis then x equals to 0. Clear? So remember these points. Now we have learned about the distance formula in grade 10th, that if we have 2 points P and Q, P is x1 y1 and Q is x2 y2, then the distance PQ is under root x2 minus x1 whole square plus y2 minus y1 whole square. And we have already learned the section formula also in grade 10th, that if we have point P and Q, P is x1 y1, Q is x2 y2, then the coordinate of the point R, which divides the line segment PQ in the ratio M ratio and internally, is given by m1 x2 plus m2 x1 upon m1 plus m2 x coordinate, and m1 y2 plus m2 y1 upon m1 plus m2 y coordinate. Clear? So pause and note down these formulas. Then we have already learned about area of triangles, that if the vertices, that is a x1 y1, b x2 y2 and c x3 y3 are the vertices of a triangle, then the area of the triangle is half modulus x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. And if the area of the triangle is 0, then we say that 3 points A, B, C are collinear. That whenever we have to prove that 3 points are collinear, we can simply find the area of the triangle, and if the area of the triangle comes out to be 0, then the points are said to be collinear. Clear? So remember these points. Now coming to the new topic, that is slope of a line. Now if a line makes angle theta with the positive direction of x-axis, then the slope is defined to be m equals to tan theta. We denote the slope by small m, and m is equal to tan theta, where theta is the angle that a line makes with the positive direction of x-axis. Now few points, that if a line is parallel to x-axis, its slope is taken to be 0, and if a line is parallel to y-axis, then its slope is tan 90 degree, which is not defined. We know that tan 90 degree is not defined. Now two lines having slopes m1 and m2 are said to be parallel if their slopes are equal. That is, if m1 is equal to m2, then the two lines will be parallel, and the two lines having the slopes m1 and m2 are said to be perpendicular if the product of their slopes is -1. That is, if m1 m2 is equal to -1, then we say that the two lines are perpendicular. Clear? So pause and note down these points. Now slope of a line. Other definition, that if we have 2 points, that we have a line segment joining 2 points, that is a x1 y1 and b x2 y2, then the slope is given by m equals to y2 minus y1 upon x2 minus x1, or y1 minus y2 upon x1 minus x2. Clear? So slope of a line is equal to differences of the ordinates upon differences of the abscissa. Clear? So pause and note down the point. Next we have angle between two lines. We have, if theta is the angle between two lines having slopes m1 and m2, then the angle between the lines, that is tan theta, is given by plus minus m1 minus m2 upon 1 plus m1 m2. And we generally take the angle between two lines as acute angles. Then we write tan theta equals to magnitude, modulus of m1 minus m2 upon 1 plus m1 m2. So whenever we have to find the angle between two lines where slopes are known, then we simply use the formula tan theta equals to modulus m1 minus m2 upon 1 plus m1 m2. Clear? So pause and note down the point. Now again, a different approach to collinearity. Previously I've told you that whenever we have to prove that the points are collinear, three points are collinear, we simply prove that the area of triangle is 0. Now if we want to prove this using the concept of slope, then 3 points P, H, K, Q, x1, y1 and R, x2, y2 are such that slope of PQ is equal to slope of QR. If this condition is satisfied, that is y1 minus k upon x1 minus h is equal to y2 minus y1 upon x2 minus x1, that is the slopes of line PQ is equal to slope of line QR, then we say that the 3 points are collinear. Clear? So whenever we have to prove that 3 points are collinear, either we can use that area of triangle concept or we can use the concept of slope. Clear? So pause and note down this point. So keeping all these points in mind, let's start exercise 10.1. And the question 1 is, draw a quadrilateral in the Cartesian plane whose vertices are minus 4, 5, 0, 7, 5, minus 5 and minus 4, minus 2. Also find its area. So we can simply draw the quadrilateral by putting these points minus 4, 5, 0, 7, 5, minus 5 and minus 4, minus 2. So we get the quadrilateral A, B, C, D as shown in the figure. Now area of the quadrilateral can be obtained by adding the area of triangle ABD and area of triangle BCD. So if we find the area of triangle ABD and area of triangle BCD and add them, we will get the area of quadrilateral. So using the formula for the area of triangle, which is half modulus x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. For both the triangles, we get the area of quadrilateral ABCD as half modulus minus 4 into 7 plus 1 plus 0 into minus 2 minus 5 minus 4 into 5 minus 7 plus half modulus 0 into minus 5 plus 2 plus 5 into minus 2 minus 7 minus 4 into 7 plus 5. On simplification, we get the area as half into 28 plus half into 93, which is equal to 14 plus 46.5. So area of the given quadrilateral will be 60.5 square unit. Clear? So pause and note down the solution. Moving to question 3. Find the distance between the point P x1 y1 and Q x2 y2 when PQ is parallel to the y-axis, and second case is PQ is parallel to the x-axis. Now when PQ is parallel to the y-axis, so if PQ is parallel to y-axis, then x is constant, so x1 will be equal to x2. So applying the distance formula, PQ is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. Now since x1 is equal to x2, so x2 minus x1 whole square will become 0. So we get PQ equal to under root y2 minus y1 whole square, which is equal to magnitude of y2 minus y1. Clear? And the second case is when PQ is parallel to x-axis. In that case, y1 will be equal to y2, because parallel to x-axis means what? Y is constant, so there is no change in y. So y1 will be equal to y2. So PQ is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. So since y1 equals to y2, so y2 minus y1 becomes 0. So we get PQ equals to under root x2 minus x1 whole square, which is equal to modulus x2 minus x1. Why modulus? Because it is a distance, we will take only the positive sign. Clear? So pause and note down the solution. Next is question 5. Find the slope of a line which passes through the origin and the midpoint of the line segment joining the points P 0 minus 4 and B 8 0. So this line is passing through the origin and the midpoint of point P and B. So let M be the midpoint of PB. Then using the midpoint formula, coordinate of M will be 0 plus 8 upon 2 and minus 4 plus 0 upon 2. So we get the coordinate of M as 4 minus 2. And since the line is passing through origin 0 0, so slope of the line OM will be, using the formula, y2 minus y1 upon x2 minus x1, we get minus 2 minus 0 upon 4 minus 0, which is equal to minus 2 by 4. So the slope of the line OM will be equal to minus half. Clear? So pause and note down the solution. Next is question 6. Without using the Pythagoras theorem, show that the points 4, 4, 3, 5 and minus 1 are the vertices of a right angle triangle. Right angle triangle, but we are not supposed to use the Pythagoras theorem. So let the 3 points be A, 4, 4, B, 3, 5 and C -1. So M1, slope of AB is equal to y2 minus y1 upon x2 minus x1. 2 points are known, so we can find the slope. So we get 5 minus 4 upon 3 minus 4. Slope of AB is equal to -1. Similarly, M2, slope of BC will be -1 minus 5 upon -1 minus 3, which is equal to 3 by 2. And M3, slope of AC will be equal to -1 minus 4 upon -1 minus 4, which is equal to 1. Now we can see that the M1 into M3 is equal to -1. So the product of M1 and M3 is equal to -1. We have learned that two lines are perpendicular if the product of their slopes is -1. So since AB and AC are perpendicular to each other, therefore it will be a right angle triangle. Clear? So pause and note down the solution. Moving to question 9. Without using distance formula, show that the points -2, -1, 4, 0, 3, 3 and -3, 2 are the vertices of a parallelogram. So we have drawn a quadrilateral ABCD with the given coordinates. Now we cannot use the concept of distance formula, but lines will be parallel if their slopes are equal. So we are going to use that concept. So finding the slope of AB, y2 minus y1 upon x2 minus x1, we get slope of AB equals to 1 by 6. Similarly, slope of DC, so using same formula, we get 1 by 6. Now slope of AB is equal to slope of DC, so AB is parallel to DC. In the same way, we can find the slope of BC, which is equal to -3. Slope of AD, which is equal to -3. So again, slope of BC equals slope of AD, so BC is parallel to AD. So since both the pairs of opposite sides of the quadrilateral are parallel, therefore it will be a parallelogram. Clear? So pause and note down the solution. Moving to question 10. Find the angle between the x-axis and the line joining the points 3, -1 and 4, -2. Now the slope of the line joining two points A, 3, -1 and B, 4, -2, using the formula y2 minus y1 upon x2 minus x1 will be equal to -2 minus -1 upon 4 minus 3, which is equal to -1. Now if the line AB makes angle theta with the positive direction of x-axis, then its slope is tan theta. So tan theta is equals to -1. So -1 means what? Minus tan 45. So tan 180 minus 45, that is tan 135. So we get the angle as 135 degree. Clear? So pause and note down the solution. Moving to question 13. If 3 points H0, A, B and 0, K lie on a line, show that A upon H plus B upon K equals to 1. Now it is given that the points P, H0, Q, AB and R, 0, K lie on a line. Therefore they are collinear. So slope of PQ will be equal to slope of QR. We have learned this property. So finding the slope of PQ and QR and putting them equal, we get B minus 0 upon A minus H equals to K minus B upon 0 minus B, or B upon A minus H will be equal to K minus B upon A. So cross multiplying and simplifying, we get HK is equal to AK plus HB. So dividing by HK, we will get 1 equals to A upon H plus B upon K, or conversely A upon H plus B upon K equals to 1, which is the required proof. Clear? So pause and note down the solution. Moving to question 14. Consider the following population and year graph. Find the slope of the line AB, and using it find what will be the population in the year 2010. The graph is given. So slope of the line is equal to what? Y2 minus y1 upon x2 minus x1. So slope of AB is 97 minus 92 upon 1995 minus 1985, which is equal to 5 by 10, that is half. Now let the population of the city in 2010 be p crores. Then the point C 2010 and comma P lies on AB. So slope of AB will be equal to slope of BC. So applying the concept, we get half equals to P minus 97 upon 2010 minus 1995. So half equals to p minus 97 upon 15. So cross multiplying and simplifying will get the value of p as 104.5. So the population of the city in the year 2010 will be 104.5 crores. Clear? So pause and note down the solution. With this, we end the exercise 10.1. So solve the remaining sums and don't forget to solve the examples given before the exercise. Okay, thank you and all the best.